Hey everyone, welcome back. This is lesson 8 of Machine Learning Zoomcamp session 3. And in this lesson, we will talk about encoding categorical variables with one-hot encoding. So if you remember in the previous session in regression, when we were predicting the price of a car, we already looked at a way to encode categorical variables. And it was by converting one categorical variable in a bunch of binary variables. So this way of encoding variables is actually called one-hot encoding. And this is what we will use in this lesson as well, except instead of implementing it ourselves, we will use scikit-learn for that. Just a quick reminder, one-hot encoding. So let's say you have a variable contract. Let's say we have two variables. So we have a variable. So one is could be, let's say, gender, and another one is contract. And we have some observations. So, for example, the first client could be female on a 2-year contract. Then the second one is female on 1-year contract. Then we have male on monthly contract. Then we have male on a yearly contract. Then let's say female on yearly contract. Then male again on monthly contract, and then male on 2-yearly contract. So we have these two categories, gender and contract. So what we want to do is use one-hot encoding to encode these variables. Here for gender, we have two variables, female and male. And for contract, we have monthly, 1 year, and 2 year. So in total, we have 5 different values. So let's create a matrix with 5 columns. First two for gender, and second, the last 3 for contract. For gender, we have female, male, and for contract, we have monthly contract, a yearly contract, and 2 years contract. So we have this table, and now the way we encode this categorical variable is, let's say, if our customer is a female, then for gender female, we put 1. And so here, let's put 1 for all the females. And likewise, if gender is male, then we put 1 here, right? And then let's do the same for contract. So for monthly contract, so this person is on a monthly contract, this person is on a monthly contract. So this person, so the second row, they're on a yearly contract. So this one is also on yearly contract, and the rest are on 2 years contract, right? So this way, so we put 1s and the rest are 0s. Let me just make it a bit thicker. Okay, so if you're wondering where the name comes from, so hot here means that the value that is activated. So for example, so for this column, for gender equals male, this value, once are hot, they kind of get activated, and we activate them by placing a 1 there. And these values are deactivated. They are cold. We place 0 there. So I think it originally comes from the name comes from electronics. So if there is a currency flowing through a connector, then it's kind of hot. Then it's encoded as 1. This way of encoding categorical variables is called one-hot encoding. In the previous lecture, we implemented this manually, but we don't need to do this manually. So we can just use scikit-learn for that. So in scikit-learn, we use, so there's a feature extraction package. And there are many ways of implementing one-hot encoding. So you use DictVectorizer. So DictVectorizer vectorizes dictionaries. So what we actually need to do is let's use a train dataset and take a look at these two variables that we have, gender and contract. So let's take a look at the first 10. So we have this small data frame with females, males, and types of contracts. And yeah, so what we can do now is turn it into a dictionary. So using this toDict method, and then we need to say that we want each row to turn into a dictionary. For that, because if we don't specify anything, then what will it do? It will turn each column into like a dictionary. Right, so we want to do it row-wise. So that's why we say orient records. So each record we want to turn into a dictionary. And so let me just do it one more time so you see. So for this one, so it just encodes gender, female, contract, 2 year. So basically each record turns into a dictionary. So let me call it dicts. And then what DictVectorizer is doing. So let me call it DictVectorizer. So we first create a new instance of this class. And what we need here is a method fit. So first we we train our DictVectorizer, and by training I mean we show it. So this is how our data looks like, and then from that the vectorizer infers that okay, there are these columns, there are these values. That's why at the end, after the conversion, the data will look this way. And it's called vectorizer because we take a dictionary and turn it into a vector. That's why it's called vectorizer. Okay, so we feed it, and then what we do next. So now it learns what kind of data is there. So yeah, let's first transform and then we'll look at, so we can transform. So here it actually produces a sparse matrix. So a sparse matrix is a special way of encoding data when there are many zeros. So if you can, if you see that there are a lot of zeros, so most of these values here in this matrix are actually zeros. And if you imagine that if we have a lot of categorical variables, most of them, like for one-hot encoding, most of them will be zeros. So that's why this sparse matrix is used. So this is a compressed sparse row format. If you're interested to learn more about this, you can just look it up. So it comes from SciPy, so you can learn about like what it is actually and how it's implemented inside. So we will not use sparse matrices here. So we will say sparse false. So this will return a usual numpy array. And we see here that probably we only have 2 year, month to month. So we don't have yearly here. So maybe we should take a bit larger example. Yeah, so here we have 1 year. So let me take a larger data frame, a subset of data frame, and we see that it actually created 5 columns. So 2 for gender and 3 for contract. So I think it's first contract and then gender. So we can actually look, check the names, so get feature names. So there is this method in the vectorizer that returns the feature names. So here what it means that for this, for the first column, this is for the first element here, this is the column. For the second, that's that one. Then for the third one, and then so on. So here the first 3 are for contract, and the last 2 are for gender. So here this value gets activated and this value gets activated, and the rest are zeros. And likewise, so here it means that contract is 2 years and gender is female. And then for this one, it means that contract is month to month and gender is male. Right, so this is how we can use the DictVectorizer. So first we turn our data frame into a bunch of dictionaries, and then we fit our DictVectorizer by basically showing all the dictionaries, and then it infers what are the column names, what are the values, what are the variable names, what are the values there. And based on that, it creates this one hot encoding feature matrix. And DictVectorizer is quite smart in a way that if we, let's say, if we have also tenor here, so let's say we have a data frame with 2 categorical variable and 1 numerical variable. So let's add it here. So this is how now records in our dictionary look like. So gender female, contract 2 years, tenor 72 months. So now if we again run this, so DictVectorizer is smart enough to see that this is actually a numerical variable, and for numerical variables, it leaves it intact. So it doesn't perform any transformation to this last column. And this last column is exactly this new categorical variable that we just added, right? And the rest is again. So this is contract, this is gender, and this one is tenor. Okay, and we, instead of just giving it 3 values, we can actually get all. So let's do that. So we can create train dictionaries. So this will be dictionaries coming from the train data set. So let's take all the categorical variables and numerical ones. And of course, we will take all of them, not just first 100. And yeah, we can see that this is how it looks like. So we have all the values here from gender to total charges. So all the values from the data frame that we have. So and each record in our list of dictionaries looks like that. Right? So we have a bunch of records. And then what we do, we fit our DictVectorizer. And then so for our so I should have fitted on train dictionaries. And then our feature names becomes a quite large list. So basically, for each variable, it has here a group. You see, so monthly charges is numerical. Then for each categorical variable, there is a group of binary variables, right? These are the feature names, and yeah. So let's take a look at what happens, let's say, when we transform first 5. Actually, need to take the train dictionary. Yeah, so maybe round it a little bit. Yeah, it doesn't help. Yeah, rounding doesn't help. Let's take a look at the first row and maybe convert it to a list. It's long, but yeah, you get the idea, right? So it's a bunch of one hot encoded variables, then a numerical one, then again a bunch of one hot encoded ones, and then again 2 numerical ones. So this is how our feature matrix looks like, and we can actually. So let me remove that, and yeah, we can actually chain this. So we can just immediately say we create an instance of dictionary vectorizer and then fit it immediately. Or maybe what is more interesting to do, we can fit the training dictionary and immediately transform it. So, and then it will be our X train. Fit transform. So it will be our X train. So here what it does, it's basically writing this is writing, it's the same as writing so first fit, doing the fit, and then doing the transform. So these 2 expressions here are actually identical. So we can see it in the shapes here. So, and here, if we execute it with the different ones, we get actually the same one. So this is just a shorter way of writing this. So because we fit first train dictionaries and then transform train dictionaries again. And yeah, so let's keep the shorter one, and we can do the same thing for our validation data set. So let's call it validation dicts, data frame validation. Okay, and now we, instead of fit transform, we use only transform. so we don't fit on the validation data set. Okay, so we have that. So again, so what we do is we take all our variables, categorical, numerical, put them into a dictionary. Then we fit a dictionary vectorizer to teach the vectorizer what kind of values are there. Then we get these dictionaries and transform them into a feature matrix that we will use for training. Then we do the same with validation data set, only this time we apply the transform function to get the feature matrix for the validation data set. So now we have the feature matrices for training and validation, and we are ready to train our model. And this is what we will do next.